Good morning. We're continuing with our next lesson in isometric sketches, and we're going to focus on how we can make our isometric sketches better. All of us can generate an isometric sketch. Some of us are going to do fantastic sketches, some of us not as great, but all of us have some room for making them better. In order to make them better today, we're going to focus on three things. We're going to talk about what it means for something to be to scale. We're going to talk about defining your light source, and then how we use the light source to create shading. So first of all, we need to know, what does it mean to draw something to scale? When we draw something to scale, it means that the parts of the object are the correct sizes relative to the other parts. So if you think about having a caricature sketch done, if you've been to a carnival and somebody has done a caricature of you or somebody you're with, the whole sketch is smaller than the actual person, but it's not shrunk the same way. So usually in a caricature, the head is much bigger than the body, and the body is this like super teeny tiny, and it adds to like kind of the comedy or the humor of the sketch. When we draw something to scale, we can't do that. If we're going to shrink the head down by a certain amount, then the shoulders, the hips, everything else has to be shrunk by the same amount. So to make this more mathematical, it means that all the parts are either enlarged or shrunk using the same ratio. This means they are proportional. So to go math teacher-y on you, a proportion is the equal ratios. Okay, that's what a proportion is. We have like two equal ratios. So for example, 2/4 is equal to 3/6. When you compare the 2 to the 4, okay, you double the 2 to get the 4, you double the 3 to get the 6. When you are doing a scale sketch or something to scale, it means you take the actual physical measurement, whether it's like a 4 or a 6, and when you put it on your paper, you shrink it by the same ratio. So the 4 becomes a 2, the 6 becomes a 3, the 10 becomes a 5, and so forth. You don't do the 4 to a 2 and then the 6 becomes a 1. Okay, because that would distort the object. If you're taking a small object and you're making it bigger on your sketch, then you're enlarging it. If you're taking a large object, then you would shrink it down to fit it on your paper. Ideally, we would measure every side. We would measure every detail of the object, and then we would use our ratio to calculate the exact length that we need our sketch to be. Realistically, this takes too much time, and we usually measure the key features and then do the rest using our intuition. So by key features, I would mean at the very least the length, the width, and the depth. You want to make sure that the overall dimensions of your object are correct, and then maybe some key features inside that. So if you were doing like the truck, you would have like the length of the truck, the height of the truck, the depth of the truck. You'd also probably want the wheels to be proportional. You wouldn't want like the truck drawn with like these teeny tiny wheels that clearly weren't the same proportion. All right, scaling. Isometric pictorials are drawn in proportion so that the relationships among the size, shape, and position of the different parts of an object are accurately represented. If we represent an object in a drawing using the actual size of the shape and object, we say that the drawing is full scale. So if you create a full scale drawing of a 2-inch cube, you draw each edge of the cube 2 inches long. You would do full scale drawings of fairly small objects, because remember, you're fitting it on a piece of paper. But if you think of like the Lego blocks, you could do those full scale. You could also enlarge them because you could get more depth and more detail by making them bigger. But if the actual size of like the object is 2 inches and the line that you draw on your page is 2 inches, that's what's called full scale. Full scale. So that's when you do not change the length at all. All right, we often reduce the size of an object in a drawing when the object is large, or enlarge the object in a drawing if the object is small. Like that's, I hope, common sense. For example, the chair, as represented in the isometric sketch in figure 5, is much smaller than the real chair. You can take your fingers and put it up to the what you're viewing, unless it's a dollhouse chair, which it could be, like the actual chair is probably much larger. But the size and shape in the drawing is my accent came out again, is proportional. It resembles the real chair. If we reduce or enlarge the size of the object in the drawing, we refer to the drawing as a scale or scaled drawing. Now, to think about this, sometimes it's easier to think about, well, what would it look like if it wasn't to scale? If that drawing wasn't to scale, maybe the legs would be way too tall. Like you'd have these legs that were just clearly not drawn correctly. Like you wouldn't have this super tall skinny chair, or maybe the back would be too tall, or some aspect of it could be too wide and it looks like more like a bench instead of a chair. To draw a scale drawing or sketch, we use a ratio to indicate the amount by which the drawing is enlarged or reduced. And you're always either multiplying or dividing. So this isn't about like adding numbers on, okay? We don't add the same number to each. We multiply by the same number or divide by the same number. Sometimes it's called the scale factor. So I know I'm going all math teachery on you, but factors are things that are multiplied to give you a product. So you would enlarge or shrink by the same factor. If it's getting bigger, the factor is greater than 1. If it's getting smaller, the factor is less than 1. So you multiply by 1/2 or divide by 2. So the scale of a drawing is shown on the drawing and is often represented as a pair of numbers separated by a colon. When you study ratios in middle school, you talk about the different ways that you can express a ratio. Most of the time in math class, a ratio is represented as a fraction. So it's represented as that division, which has advantages to it. When you represent things as a fraction, it means you can do with the number all the things that you could do with a fraction. When talking about scale, though, it is often using that colon notation. So just keep that in mind. Now, down at the bottom here, they do tell us what the numbers represent. So the first number represents the length of the object as shown in the drawing. The second number represents the actual length of the object. We can also think of this ratio as a fraction, 1/5. So this would be the drawing size. Maybe the drawing size is, now we need some units with that. So it could be something like 1 inch. And the actual size could be 5 inches. And you would specify the units in that. You don't have to stick to the same units, although it is convenient to make sure like you stick to the same units. We don't want to overcomplicate things. All right, scaling a sketch example, using 4x4 graph paper that is 4 grids per inch in both directions. Assign a grid spacing of 1/2 inch. You can do when you're sketching them, you can do actual measurements. But if you're using graph paper, you can sometimes just scale it by the grid size, which is actually pretty convenient. So you could say 1 inch equals 1 of the little grids. Now in this example, they go into more depth there. So it says assign a grid spacing of 1/2 inch. If an edge on the object is 3 inches long, then you would need 6 spaces or 6 grids in order to draw it to scale. You can verify this mathematically, and then they do a calculation, probably not how I would ever do it, but they do 6 spaces times 1/2 inch per space equals 3 inches, and that's how you can use the scaled graph to figure out or scaled drawing to figure out the actual size of the object. If you measure the line on the graph paper with a ruler, the line will measure 1.5 inches long. Therefore, the scale of the drawing is 1:2. That's harder than I would make it. So we'll try to simplify that when we go to do it. Okay, let's talk a little bit about shading. Shading can make it realistic. It actually does a lot to take a sketch that might otherwise look a little bit cartoonish and make it look a lot more realistic. Now, shading your sketch by adding the appearance of shadows and light can make your sketch appear more realistic. Using different values, the lightness or darkness of your pencil marks will create the perception of a light shining on the object. And that does a lot to make your sketch look three-dimensional. So those of you that struggle with making your sketches look realistic, this can do wonders. It does take some practice, because if you get the shading wrong, it will look distorted, but it's actually pretty easy to get it right. A value scale can help you select appropriate values for a sketch. The values included in a value scale will vary depending on pencil hardness, pencil sharpness, and the paper you use for your sketch. Once you create a value scale, you can compare it to the appearance of a real object to select the best value for your sketch. And what I like about that, like, you don't have to overthink it. I almost think that's really overthinking the idea there, is that you want to use a variety of different shading in your sketch. Don't lock yourself into no shading, but also don't lock yourself into it's either shaded or unshaded. There are different values of shading, and there are areas that might be much darker than others. Just one word of caution, because my algebra students will do this when they shade stuff for inequalities. Don't shade something so darkly that you obscure details in the sketch. If your shading is so dark that you can no longer see something that's in the sketch as one of the details, you've gone too dark. Okay, so picking the light source, how you want to shade it is not haphazard. You don't want to just randomly try to shade something. You want to be deliberate. So when you shade a sketch, it is important to identify the light source so that you shade the object faces consistently. Otherwise, you may tend to haphazardly choose values without thinking about how the light would really create shadows. Once you have identified the light source, determine how the light will affect each surface of the object. Surfaces closest to and facing toward the light will be lighter. Surfaces further from and facing away from the light will be darker. Don't overthink this. And in fact, a lot of the sketches that we were doing last year when we did this, I would have students like put the little like sun somewhere in their sketch. And I want you to do that as well with the sketch that we will be looking at next. Actually put like the little sun somewhere in your sketch so that we can see where the light is coming from, and that will help you decide how to shade it. Now, if you look at this one here, it does have 3 different values of shading. So the top is light. The light source has a completely unobstructed angle there. Then this side here, I don't know if you guys can see where my pointer is right there, is hidden from the light source. It's not hitting that at all. That's the darkest shade, as is this down here. Okay, now this side here is facing away from the light, but isn't as obstructed as this. Like this, the object itself is blocking it. So they've used a middle shading value. And then the people who did this marked that face right there where I'm putting the dots as the as also lightest. Some people might argue that there will be some kind of shadow there, and they might go with like a 4th value for the color of their shading. Some of that's up to you. What's important is that you're not ignoring the shading altogether, and be intentional about it. Find your light source, pick your light source, and then shade accordingly. So we're going to take probably the remainder of the class period. I want to allow plenty of time for you to do this and to do it well. So I would like you to sketch the figure below. Pay attention to both scale and shading. Don't rush this. Don't throw something onto your notebook paper and say, okay, well, I did my sketch. I want you to pay attention to both the scale and the shading. Scale and shading. So take a look at this. It tells you the scaled isometric sketch of form 3 shown in figure 6. That's this. The actual form is constructed of 6 1-inch cubes. So I'm gonna mark this diagram up a little bit. and then I'll erase it so that you can be clear what you're seeing. This is considered 1 inch, as is this and this. So that's 1 inch. Now, because this is considered to scale, this right here would be 2 inches. So what you can do is you can actually divide this up into 1 inch cubes. So we have like 1, 2, 3, 4, 5, and then the 6th one would be in that back corner. And I know my lines are super crooked there. So look at what you're drawing yours on. If you were able to print the isometric graph paper, decide like how many grid marks is going to be 1 inch. Do you want 1 grid mark for 1 inch? Do you want to do like 4 per inch? Maybe you'd like to do 6 per inch. Just I will say this, be like really careful, because with the isometric graph paper, it is super easy to start your sketch in a particular spot and then to realize you don't have room to finish it. So that's another reason I want to allow plenty of time to do this, because you might get partway through your sketch and realize that you have to redo the whole thing because you have to move it on your page. If you're doing it on a piece of notebook paper, I would like you to be intentional about this. You don't have to use a ruler necessarily, although a ruler will be helpful. But grab something that you can measure out on, like even if it's like the edge of an index card, so that you know what you're using for your scale. Then identify your light source. Actually draw a little sun somewhere. And if you want to be adventurous, you can like draw it from a different angle. Draw your light source coming from somewhere else, so we don't get in too much of a rut. If you've got time and you'd like to try to draw this from like with different light sources and experiment with your shading, that's awesome. I'll let you guys do that. Let me clear this up. That's a bit of a mess. And I will allow the rest of the class period for you to do that. Make sure you're paying attention to your light source. And if you would like to email or send me a copy of it, we can actually start Friday's class by looking at some of them. I'll keep you anonymous if you would like. We can just kind of discuss what was good, what was bad. Tomorrow I see you for the baseline. I'll hand out some isometric graph paper to everybody who doesn't have any. And then we'll wrap up isometric sketching on Friday.